Hello, we're looking at problem number 2 found on page 266 in your textbook. This is lesson 4-7, talking about congruence in overlapping triangles. We can see two overlapping triangles here. Now we're given that ZXW is congruent to YWX. And if you'll look, that's the little red marks that have been given here, okay? And then we're also given that ZWX is congruent to YXW, which are the two bigger blue tick marks that are over here. They kind of, again, because they're overlapping, sometimes visually that becomes hard to see. And what we're trying to prove is that ZW, this line right here, is going to be congruent to this line right here. And so what they're trying to get you to do is, if we could separate these, if we could pull this triangle out to make it look like this, and we could pull this triangle out to make it look like this, and still keep the tick marks, the big tick mark here would end up here. The little one right there, the little red one, would end up right there. Same way here, the little red one would end up here, and the big tick mark there at X would end up right here. Okay, so we already have two angles that are congruent to each other. As we let me lower this just a little bit. As we go down through here, we have two. Now remember, to prove triangles are congruent, we've got to either pick angles, side angle, side angle, side, 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 or angle, angle, side. And so as we look down through here, we've already got an angle and an angle matching an angle and angle of the other one. And if we look very carefully, we also know that WX and WX is the same line. Even though it's separated out now, it was the same line. And because of reflexive property of congruence, this line is congruent to this line. So if we look carefully, we have an angle, a side, and an angle congruent to an angle, a side, and an angle. So therefore, these two triangles are congruent to each other by what we call angle, side, angle. And I know that looks a little messy now. Let me just go back. So by angle, side, angle, those two triangles are congruent. And if they are congruent, then this side is going to be congruent to this side, because corresponding parts of congruent triangles are congruent. Sometimes we just say CPCTC, which is really the same thing. It just is an easy way to abbreviate it so that we don't have to write all those words. Congruent parts of congruent triangles are congruent. Okay. Now let's look carefully at this next one. Now it's a little bit more complicated. Usually we would separate these out. However, in this particular one, it tells us that triangle ACB is congruent to triangle BDC. Okay, so I'm going to leave them kind of overlapping here, and kind of for a reason. So it's saying that ACD is congruent to BCD or BDC. Those are congruent to each other. So usually we're trying to prove congruence like we did here. But this is starting off saying that they're congruent, and we're trying to prove that CE, that this piece right here is congruent to this little piece right here, which is not the full piece of the triangle. And so what we've got to do is, let me erase that little part right there. If those two triangles are congruent, we know a couple of things. First of all, if the two triangles are congruent, we know that this side is congruent to this side of the overlapping triangles. We, of course, we know that vertical angles are always congruent to each other, okay? And we know that that angle is congruent to that angle, see, I'll use 2 tick marks there instead of 1 so we can tell the difference. So A is congruent to B, and we can pick that from here and here. We know that side AC is congruent to side BD based on the congruency theorem, and of course angle E, even though it's not a part of the congruency statement here, they are vertical angles, and we know that they're always congruent. And so if we look carefully, this triangle right here and this triangle right here, they are congruent to each other. So what I'm trying to say is triangle AEC is congruent to triangle BED because of angle, side, because I have 2 angles and a side not included, congruent to 2 angles and a side not included of the other one. So those 2 triangles are congruent. And if they are, then I can come along and say that CE right here is congruent to DE right here. CE is going to be congruent to DE because corresponding parts of congruent triangles are congruent. So once I prove they were congruent, then every part of that triangle is going to be congruent, including CE and DE. So I know that's a little tricky, and it is a little bit more complicated when they're overlapping, but I hope this was a little bit helpful for you, and you can use this as you work through this section.